The order of integration states that the integral from b to a of f of x dx is equal to the negative integral from a to b of f of x dx. Using the order of integration, the integral from 4 to 5 of x plus 1 dx would equal the negative integral from 5 to 4 of x plus 1 dx. The zero property means that the integral from a to a of f of x dx is 0. So basically, the integral from any number to itself would be 0. Using the zero property, the integral from 5 to 5 of 2x squared dx would be 0. The constant multiple means that the integral from a to b of k of f of x dx is equal to k times the integral from a to b of f of x dx. So you just pull out the constant to outside of the integral. Using the constant multiple, the integral from 4 to 7 of 10 times the quantity x squared plus 1 dx, you could just pull out the 10 to the front of the integral, so it would equal 10 times the integral from 4 to 7 of quantity x squared plus 1 dx. The sum and difference property is the integral from a to b of f of x plus or minus g of x dx equals the integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. So basically, if there's two functions inside of one integral that are separated by a plus or a minus, you can separate the two functions out. Using the sum and difference property, the integral from 1 to 4 of the quantity 3x minus 4x squared dx can be broken up into two separate integrals, so it would equal the integral from 1 to 4 of 3x dx minus the integral of 1 to 4 of 4x squared dx. The additivity property reads that the integral from a to b of f of x dx plus the integral from b to c of f of x dx equals the integral from a to c of f of x dx. So basically, if there's two integrals added together, and so like the first one ends with b, and the next one starts with b, you can just make it one integral instead of two. Using the additivity property, the integral from 1 to 4 of 14x cubed dx plus the integral from 4 to 6 of 14x cubed dx, since one integral ends with 4 and the next one begins with 4, and it's both 14x cubed, you could just make it one integral from 1 to 6 of 14x cubed dx. Here's some more examples for you to solve. Pause the video, solve them, and the answers will follow. So basically, these different properties help to make the integration easier. They may seem unnecessary now, but eventually these little properties will help you to solve much more difficult integration problems.